Welcome learners. This is module 2 for unit 2 mineralogy. In this module we will be seeing physical properties of minerals. My name is Sarath Kumar. I am working as an assistant professor in Department of Civil Engineering, GCE Dharmaburi. So the various physical properties of minerals are crystal, form, color, streak, luster, fracture, cleavage, hardness, density and specific gravity. In this module we will be seeing these physical properties and how with these physical properties you can differentiate the various minerals. First we will be seeing about crystal. A crystal may be defined as a natural solid body bounded by smooth and plain surfaces arranged in an orderly manner, which is an outward expression of internal atomic structure. All substances are made up of atoms or molecules only, but only in case of solids they will be in fixed positions based on whether these occur in any definite pattern or occur in a haphazard or disorderly manner. These solid substances are described as crystalline or amorphous substances. In nature, more than 99% of minerals are crystalline. As we see in the definition of mineral, the mineral should be of solid nature. So the atoms and molecules will be in fixed positions. Based upon how the atoms and molecules are fixed, how it is occupying the position, the minerals will. So based on the number of crystallographic axes, their relative lengths, their interchangeability, their mutual angles, the crystals are grouped into 6 crystal systems. The 6 crystal systems are cubic, tetragonal, hexagonal, orthorhombic, monoclinic and triclinic systems. These systems and how the atoms are occupying the position is shown in the left figure. The first one is cubic, where all the sides ABC are the length of the 3 perpendicular sides and alpha, beta and gamma are the respective angles each two perpendicular sides or each two sides makes. In cubic, all the sides are same and all the angles between the respective sides are 90 degree. So such crystal system are called cubic system. In tetragonal, only 2 sides are equal and the third side will be different from the first 2 sides and all the angles will be 90 degree. Whereas in orthorhombic system, all the 3 sides are different in length, but the angle between any 2 respective sides are 90 degree. In hexagonal system, similar to tetragonal system, 2 sides are equal and the third side is different from the first 2 sides. Whereas the angle will be the 2 angles will be 90 degree and the other remaining angle will be 120 degree. In monoclinic system, all 3 sides will be of different length. 2 angles between 2 respective sides will be 90 degree and the third one will be not equal to 120 degree. It's not equal to 120 degree. It can be any angle. Whereas in triclinic system, all the 3 sides are of different length and the respective angle between any 2 different sides will not be 90 degree. It can be of any sides. So based upon the length of the 3 sides and based upon the angle between 2 respective sides, the crystal system we are classifying into 6 systems, out of which cubic is the most symmetric and stable system, and the symmetry and stableness reduces as we go along tetragonal, orthorhombic, hexagonal, monoclinic and triclinic systems. Form. This is one of the first observations made when a mineral is examined. It is also called habit or structure of the mineral. It is simply what is the structure we are seeing upon the mineral. Some have such distinctive forms and we can use the property as the identification. Some of the most common forms are given here. Lamellar form. The mineral appears as thin separable layers. Examples are varieties of mica. The next form is tabular form. Here the mineral appears as slab of uniform thickness. Example, feldspar gypsum. Fibrous form. Appears to be made up of fine threads. Asbestos satin spur. Rhombic. Appears in rhombic shape. Calcite, dolomite. Prismatic form appears as elongated independent crystals, quartz. The next form is crystal, appears as polyhedral geometric shapes, quartz galena. And if it shows no definite shape, it is called as massive form. Examples are graphite and quartz. Here, as you can see, the quartz appears either as prismatic crystal or massive form. So it will not be having a definite form, the quartz mineral. So next striking property is color. Color of a mineral is often a striking property. Color is determined by chemical composition. Unfortunately, color is not a reliable means of identification. Small amounts of Fe can drastically change the color of a mineral. For example, based upon the impurities, the color of a mineral vary to a great extent. Color will change as the percentage of iron content increases or decreases. Some minerals are the same color. Some minerals are the same color as others, and some minerals can have many colors also. So, variety of minerals can have the same color, and also a single mineral can be of many colors based upon the impurities. So, color, some minerals you can identify, but it is not a very diagnostic property to identify a mineral. Streak, the color of a finely powdered mineral. It is determined by rubbing the mineral on a piece of unglassed porcelain. Powder gives a reliable color effect because all the grains are small. Here, the effect of impurities are removed. For example, red streak characterizes hematite mineral, even though the specimen itself looks like black and metallic. Hematite mineral, when you see it, resembles black or metallic, but when you strike it against a porcelain plate, it will give you a streak of red color, so that you can identify as hematite. One problem in using streak as a diagnostic property for identification of mineral is many of the minerals can have the same streak. The next physical property is luster. It is the property in which the surface of the minerals reflects light. The quality and intensity of light reflected from a mineral is used in identification of these minerals. There are many ways in which the mineral can reflect light. 5 most important lusters are: the first one is metallic. It reflects the light as of a polished metal surface. The other lusters are grouped into non-metallic group. In non-metallic group, the important lusters are vitreous or glassy. These type of minerals will reflect light as of glass. The next type is resin. These minerals reflect light as that of resin. The next one is purely. These minerals reflects light like that of pure. The next luster is greasy. These minerals reflects like a surface covered by a film of oil. In the below figure, each luster is given example. The first one is metallic luster, the second one is glassy luster, the third one is resinous luster, fourth one is greasy, and the final one is pearly. Based upon how the mineral reflects light, the lusters can be divided into either metallic or non-metallic. In non-metallic also, it is again subdivided into vitreous, resinous, pearly, and greasy. So the next type is fracture. Fracture is the nature of the randomly broken surface of a mineral. So it is randomly broken. How randomly the surface of a mineral can be broken. Like streak, it is also less useful in mineral identification because majority of the minerals shows the same kind of fracture. Based on the nature of broken surface, fractures are classified as below. First is even fracture. The randomly broken surface will be plain and smooth. Example, chalk. If the randomly broken surface is rough or irregular, it is called as uneven fracture. Most of the minerals will be having the uneven fracture. So you cannot use fracture as a diagnostic physical property in identification of minerals. The next type is Hackley. In this form, the randomly broken surface will resemble like a broken stick. It is very irregular. It will resemble like a broken stick. Normally it happens in fibrous substances. Example of those form is asbestos. The next fracture type is conchoidal. If the broken surface is smooth and curved, it is called as conchoidal fracture. Example is volcanic glasses. The next type is subconchoidal. It is very similar to conchoidal, whereas the curved part is less prominent. It will be smooth. It looks like a curve, but it's not an exact curve. Such type of fracture are called subconchoidal, and example of those type of forms are agate. So based on the randomly broken surface, the mineral fracture are classified into even, uneven, Hackley, conchoidal and subconchoidal. So the next physical property is cleavage. The definite direction or plane along which a mineral tends to break easily is called the cleavage of a mineral. You should not confuse fracture with cleavage. Fracture is randomly broken surface, whereas cleavage is the preferred weakest direction in which the mineral will break. Cleavage planes are parallel to planes of weak bonding, governed by crystal structure. Angles between crystal planes are the same for all grains of a given mineral. Cleavage is therefore a valuable guide for the identification of the minerals. Most common minerals have distinctive cleavage planes. So cleavage is the one distinctive property you can use in the identification of minerals. So these are the various cleavage types. The first one is one cleavage plane. So here the mineral break it as thin sheets. Examples are mica. The second is two cleavages at right angles. Examples are feldspar, pyroxenes. The next type is two cleavages not at right angles. Example, amphiboles. Third one is three cleavages at right angles. Halite, galena. The next one is three cleavages not at right angle. Calcite, dolomite. The next one is cleavage in 4 directions. Fluorite, diamond. The next one is cleavage in 6 directions. Sapphire. Here it is given one cleavage plane means the easiest way to break the mineral is only one plane. Whereas in two cleavages at right angle, there will be two planes in which a mineral can be easily break down. There are two weakest planes. Whereas in three cleavages, there are three weak planes, and in cleavage in 4 directions and cleavage in 6 directions respectively, there are 4 and 6 weak planes respectively. Examples of such type of cleavages are given in the right hand side figure. So we will be finishing this video with this cleavage. We will be seeing hardness in the next video. Thank you.